Okay, so now just thinking about it, I'll explain the different elements that I've got to develop. Okay, so the idea is to have the drone flying and be able to take photos or video, and then be able to send that via GSM network, which is your mobile phone network, directly to a website where people can log on and see it in real time. So there's various factors that I've got to develop. I've got to build a website. So I'm going to do that through AWS, Amazon Web Services. They seem to be the latest, greatest, thing out there. And also being something that, a crisis can pull thousands or hundreds of thousands of people together. So if you just suddenly have 100,000 people logging on out of the blue, your website's going to crash. And so the good thing with Amazon Web Services is it has like scalers and all that, load balancers and all those kind of things. And you can set it up in all the different regions. So potentially, should 100,000 people suddenly log on out of the blue because a princess has gone missing or something, I don't know, maybe, something like that. And you're now searching for this princess. I just thought of a much better analogy. Let's say your favorite rock band has gone on a snowboarding weekend, and then at some point they're like, oh, someone's like, oh, you should come check out these other cliffs. And by nightfall, they haven't returned. The next morning, there's no word. No one knows where they are. And then you have to have search and rescue, obviously, to come and find them. So we could deploy the drones. That stuff's going to hit the newspapers straight away. Like, newspapers love those kind of stories. And so suddenly you have like every fan in the world worried for their rock band's welfare. So they could actually help in the search. So the drones could fly over the search area, be taking photos, uploading it to the website, and then fans can log on. And if they spot something, you have a big sheet of snow, if they spot something in the snow, they can log on it, and then that can be checked by the search and rescue team. So the potential for this is huge, and that would be a way that you would easily have 100,000 people logging on at once, trying to help search for their favorite bandmate. Yeah. So anyway, so we've got to get the NavQ computer, which seems to be encompassed with video and photos. I don't have any experience with these computers, but they seem to be a Linux operation, so presume it can run Linux. Presume we should be able to get enough versions of our software working that we need. And so one of the elements is working out the best way to send the photos and the video. And the videos is not so difficult. You just have set up some kind of RTMP server through to, and I might even just use like Twitch as a host or another web service already as a host and just embed it in the website. That's a possibility. There's nothing wrong with that, as long as it works and it needs to retain high resolution. The photos, at the moment, I don't really know how to go about that. So you can pre-program a search area for the drone, and then you need to take photos. Do you have the photos looking downwards? Do you have the photos looking forwards? Probably downwards is what I imagine. And then how frequent do you take the photos? Maybe we could just set it up while it's doing the search area to take a photo every 30 seconds or something, depending on the speed of the drone. So if it's, we could see how far it travels and its height, I guess, needs to be above the trees so it doesn't crash into a tree. So say that the height's 20 meters and it travels, every 10 seconds it could take a photo and upload that. And also if we're doing super high resolution photos, which is what they need to be effective, need to be able to cope with the bandwidth of the GSM network to be effective. So, it's all good to snap a million photos, but it just simply won't be able to upload them. It's all good to be able to have like a red HD camera on the board or something, but it's going to be too heavy and it won't cope with the bandwidth. So these are all elements of the engineering that need to be worked out. And obviously, like everything you add to the drone adds weight, which means less flight time. Ultimately, airplanes get a lot longer flight time because the wings create the lift, whereas in the drone you've only got the 4 motors. So yes, so everything you add to it creates weight, creates less flight time, all these kind of things. So obviously you want the minimum weight on there. It's good to have a decent amount of weight. I feel like that helps in the wind. If your drone is very light, or your object is very light, it gets blown about, whereas when it's got a certain amount of weight, it tends to be more stable, in the air. And the propellers on these are huge. They're around somewhere, but the propellers, So potentially, once you add a 5,000 milliamp battery, I feel like these become quite heavy. So I feel like possibly, and today it was coping in the wind all right, but the wind was not very light, not very strong. So I feel like potentially going for more batteries. The drone doesn't need to be fast. But yeah, more batteries makes it heavier, makes it more stable in the wind. And then you've got more power to use. So I feel like that's probably going to be a good way to go. But anyway, that's a minor detail. We can simply test that down the road just by adding a big battery and see how long it flies for. Because, the more weight, the more it needs to lift. All right, so that's where we're at the moment. And if you see any details on here, this is the flight computer. It's called the FMU, which stands for the Flight Management Unit. That'll do. That sounds good. This little post here, so this is the GPS receiver. So the GPS receiver is elevated away from all the electronics to try to give it a clear signal. And if anyone's thinking that Bill Gates is going to inject people with micro trackers, that's the size of a GPS receiver. Think you're going to get that through the eye of a needle? Good luck to you. Then we obviously have our arms with the 4 motors. This is the receiver from the handheld controller. So you can fly it manually using this. So that sends a 2.4 gigahertz signal from there to there. These are the little antennas for the receiver. And you can also plug in servos direct to there. I haven't tried it, but that would be good if we're using a camera gimbal, which I presume we will be. Motorized gimbal, so the camera can be lifted up and down and stuff. So I feel like that could be potentially something that we're going to need to use. This is our telemetry receiver, and so or transmitter receiver. And so what happens is all the data, instead of plugging in a USB direct to the board and having it transmit data to the computer, it transmits it through telemetry radio. And so on the top of my laptop, I also have a telemetry radio. So this one plugs in via USB to my laptop. That one plugs in via whatever they're called, UART ports, I think, which is the same as USB. And so so that's how it transmits data to and from the laptop to the drone. So that actually brings up another point, is these, although this is long range, this is a 432 megahertz, 433 megahertz transmitter. So these are long range, but what we want to do is be able to switch it so the drone controls can go through the GSM network as well. So ultimately, you don't actually have to be where the drone is to be controlling it. You can be, you could have like a central station in Melbourne, but be searching for it for someone lost miles out in the bush. So there's different elements to like being able to achieve that. But yeah, ultimately having the control going through the GSM network, something that I want to do, and be able to switch it so you can have it controlled just right in front of you, or switch it to the GSM network. What else is in there? Inside of there's a power distribution unit, but I'm not going to take it apart at this point in time because I can't be bothered. But yeah, and the battery is going to sit on the bottom here. Connect this little map module to modulate the voltage. Yes, so that's our beast at the moment. And yeah, ultimately what could happen is instead of using a quadcopter drone, you could use a fixed wing aircraft with the same capabilities. And so the fixed wing aircraft you could have a base station, you know, in central Melbourne, and when there's an emergency, they can be deployed. And because the flight time is a lot longer, they could fly 100 kilometers out to where the search area is, you know. And that's the thing in a search and rescue situation, every second counts. You've got to like get out, you know, you've got to get there. And so ultimately you could have the craft take off from a central station, fly that 80 kilometers, go through the pre-programmed search area, be flying autonomous, and when GSM is in range, able to send the photos. And then in the meantime, you could have a search vehicle, or sorry, a base station vehicle, leave and drive out to the search area. And so if they're fixed wing aircraft, they're going to need battery changes in a few hours and things. And so they can take off, immediately fly there. Then in the meantime, the base station vehicle drives on the ground and catches up to where the search area is, and then they're able to land, put new batteries in from the base station vehicle, and take off again and continue searching. And, you know, presuming that there's a GSM receiver or what do you call it? Doubling station? That's not the right word. Like a repeater. So ultimately, like, that will be able to happen somehow. And so yeah, then the search can continue indefinitely through the day, through the night. Add thermal cameras to this, which is something I want to do, but I don't have any way to afford a thermal camera. But thermal cameras are ultimately the best way to go. Yeah, and then the search can continue indefinitely. You're not limited by human power. You're not limited by people walking around the forest. You've got these crafts doing the searching for you, and then people online at home in their lounge room helping with the search. And so the manpower is, the whole need for manpower is eliminated basically. You know, it comes down to like being able to deploy a huge search area with just a few people. And then, yeah, with the help of everyone at home helping with the search. Okay, so I think that wraps it up. That's my ambitious goal, and I've got about 2 months to do it. It's just gone September. I think you've got to enter these in November, but we're in lockdown in central Melbourne, so we're not even really meant to be going out and doing these kind of things, but I feel like sneaking out and finding an empty park and being by myself and testing this drone is perfectly okay. Yeah, it's me getting exercise, walking to the park for like a few kilometers, and then yeah, I feel like and just being by myself all day anyway, so it's not exactly even seeing any person when I go out there and do it. Alright, so that wraps up my idea, and yes, I will keep you updated on what's capping and how it's going.